So we want to ask the following question. How could we count the number of R combinations with repetition, or you could say multi-sets, without making a complete list? So even for our last example, the list kind of got long. We had 20 of them, but what if we had a whole lot of elements? We don't want to write a list every time. So let's go back to our example from earlier. So remember, we were looking at 3 combinations with repetition allowed. And we had this set that we could pick numbers from, 1, 2, 3, and 4. So here's how we're going to think about this idea, is you can think of the numbers 1, 2, 3, and 4 as categories. And what you're doing is you're choosing a total of 3 numbers from the categories. So you're with multiple selections from a category allowed. So let's kind of visualize this idea here. So we're going to look at 3 examples here. So I'll make 3 rows. There's category 1, that's the number 1. Category 2, that's the number 2. Category 3, it's the number 3. And finally, the last category, category 4. And so I'm going to use bars to separate these categories out. So let's say you pick 1 from category 2. I need to make 3 selections in total, and 2 from category 4. So what does this correspond to? It corresponds to the multi-set 2, 4, 4. You selected 1, 2, and 2 4s. Or let's say I choose 1 from category 1, 1 from category 3, and 1 from category 4. That represents the multi-set 1, 3, 4. Or I could have selected them all from the first category. That would be the multi-set 1, 1, 1. So if you look kind of at each one of these rows, what do I have? I have X's and I have vertical lines. So I have these bars, as they call them, the vertical lines, and I have crosses. I have these X's. And so what I can do is I can look at this as like arranging these symbols, these crosses and bars. So for example, if I had X, X, bar, bar, X, bar, well, this first part tells me how many I have in category 1. So I have 2 1s. There's nothing between these 2 bars, so I have 0 2s. I have 1 between these 2 bars, so that means I have 1 3. And then there's none after this last bar, so I have 0 4s. So what multi-set would this be? It would be the multi-set I selected 1, 1, and a 3. So instead of looking at choosing these numbers, I can just look at choosing where to place these X's and bars at. So the number of distinct selections of 3 elements formed from the set 1, 2, 3, 4 with repetition, it's the same as the number of distinct strings of 6 symbols consisting of 3 bars and 3 crosses. Well, really, if you're positioning those, so if I want to count this over here on the right, this on the left, I know how to count. There are 6 positions. And once I choose the positions for the X's, the bars have to go in the remaining positions. So all you need to do is choose the position for the positions for the X's. And so there are 6 positions in total, and I need to choose 3 of them. So this is 6 factorial over 3 factorial times 3 factorial, or 20. And if you remember, that's the exact same count that we had when we listed out all of the 3 combinations with repetition. So you can ask, we did this for a specific example, but you can ask, how do we generalize this? So if we have n categories, before we had 4 categories, if you remember when we had 4 categories, we had 3 vertical bars. So now you have 1 less bar. So you're going to have n minus 1 vertical bars. And then you're going to have R being how many elements you're selecting. So the number of elements chosen. And this is how many X's you have. So how many total positions do I have? The total number of positions, it's the sum of these two. So it's R plus n minus 1. And so then you're taking R plus n minus 1. That's how many positions you have in total, and you need to choose the positions for the X's. So there were R X's, so there's R. So this is the count in general. So let me write it up here formally. The number of R combinations with repetition allowed, or you can say multi-sets of size R that can be selected from a set of n elements is R plus n minus 1, choose R. So that's how we count them in general.